Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 8D. I am Pranjal Bange, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026, in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held a day before yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you'll enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for questions and answers. In 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co-host in the chat box. Just before we start the session, I would like to introduce you all to the session chair of this session, Professor Prashant Dhotre. He's working as a professor and head in the Department of Information Technology of MIT School of Engineering in MIT ADT University. He has more than 17 years of teaching and research experience. His publication includes more than 25 papers in the international conference and journals. His research interests include algorithms, privacy, and Turing machine. I would invite you to give the opening remarks, sir.
Thank you, Pranjal, for the kind introduction. Uh, this is the one of the best conferences that we have been seeing since many years, and I wish all the participants best luck. Good wishes to everyone. Thank you.
Thank you so much, sir, for those closing remarks. Now we'll start with the presentation. I would like to apologize in advance if I mispronounce any of your names. Starting with our first presenter, Guilherme Martini Dalpian would present his paper on efficient detection of child sexual abuse material in low-resource forensic environments using transfer learning with lightweight convolutional neural networks. You may start with your presentation by presenting your screen.
Okay, I will upload my presentation.
You may start with your presentation.
Okay. Oops. Just a minute, it's opening. So I'm Guilherme Dalpian. I work. Start by a chronometer here, just to don't miss the time. This article is part of my master thesis in the University of Brasilia. I'm also a police
Dear
officer.
author, your screen is not visible. I mean, I see the drive, not the presentation.
Oh. Okay, I'll try it again. Can you see it now?
Yes, sir, we can see it.
Okay, great. I'll continue. So I'm also a police officer, and I work for the Brazilian Federal Police. So I've been working more than 20 years in the Brazilian Federal Police, and mostly in this part of child sexual abuse on the internet. So this is as I work for the Brazilian Federal Police as a digital forensics expert, and so we have a problem mostly with these child sexual abuse cases, where we have a huge backlog because of every time the computers have more capacity, and you have bigger smartphones, and our people cannot get along with it very well. So we have this huge backlog. It's a problem for the investigations. Nowadays, we have some tools to search for this kind of material, mostly using hash-based methods. But these hash-based methods have some problems that you only find files that you already knew before. So it would be interesting to find new files, detect new files that you haven't previously seen on site. So here in Brazil, when we do, for example, a search warrant, it's interesting to be able to look quickly to devices on the house that you are doing your search, your investigation, to see if you find this illicit material. So nowadays, we only relied on hash-based. So we thought that maybe an IA tool to do this kind of classification of these files and find not only hash known files, but new files would be very interesting. And there is also another problem, that is the occupational health. So if we had some AI classification tool, we could expose our analysts less to this kind of content, because these files are really horrible. And if you could do all that you can do automatically helps a lot. So the idea in this article is a hybrid detection framework. But why is it a hybrid? Because you have the hash filtering, which is very fast, very useful. So you have known files that you, like, for example, Windows files, you don't need to look at that. You have our database of known files. We have more than 4 million files in Brazilian Federal Police catalog. And then after you do the hash filtering, you can do the AI classification. So you can detect new files that you haven't previously seen. For example, some altered file, or even ongoing abuse. Maybe there are some files on that computer, and you can run this tool, and you find it will show it to you because of the AI classification. So here is the methodology that we use to develop this classificator. So we had this child sexual abuse files from our Brazilian Federal Police. So I'm a police officer, and I had access to it. We had some adult pornographic files that we just downloaded from the internet, and other files that are not interesting, other image and video files that are not interesting. So, like, for example, some vacations or something, like operating system graphics that does not interest us. So this data set preparation was I think is one of the most important parts, because we had a problem that we didn't have many child sexual abuse material files compared to the other classes, like pornographic and others. So we had to do some treatment to overcome this difficulty. So here's the data pre-processing, how we managed to arrange this data set. So we do first hashing just to eliminate duplicates. And here is some interesting part, that we had this whole 400,000 files, but we had to separate it in test, training, validation, and later test data sets. So we used already AI to find similar files, so that similar files are not spread across different data sets. So test files must be different from the training files. So it's not easy to the algorithm to classify them.
Like
Train tests. Sorry. And there's this other technique was the balanced validation. So the validation class, as you can see, is the same size for all. Why did we do that? So the other class, which is very bigger, doesn't influence so much on the validation, because otherwise it would be easy to the algorithm to say, oh, everything is other, and we have a good statistics. So we did a balanced validation data set. Here's the modern architecture. So our idea was to run it really a lightweight AI classification. So we even can run it on the device that is being apprehended. So we chose EfficientNet version 2, B0, to our transfer learning. So it has a good accuracy. It's very fast, and I'll show the results. It's very suitable for our needs. So here's some details about the training. So we had the feature extraction, the fine tuning, and the model that we chose. And later we converted this model to on an X for running on the CPU. So we usually on site on the devices doesn't have good graphical devices. So we run it all on the CPU, and it has to be very fast and lightweight. Okay, so here are other techniques to the problem of the child sexual abuse files that are imbalanced, that we have too few. So we used a weighted loss function that on the training, so we could do a higher recall for child sexual abuse material, still maintaining a good precision. Okay, here is another part of this study, that we had a forensic Linux modified already with these tools embedded. So we can this is a bootable Linux environment, which many customizations like write blocking and disable swap mounts, and there's really a forensic system. So you can even run it directly on the device to be apprehended. So you just have to side load it. You have to boot, instead of the normal operating system, you boot this modified Linux, and it has already the tools. We use a forensic tool called iPad, which is an open source forensic tool, modified to have we developed a plugin with this AI classification algorithm. So this Linux already has everything that's needed to run this. You can even we did some tests on some modest computers, and we had good results. So here is the classification performance of this model that we trained. This is the EfficientNet version 2 B0. We had a 91.4% precision on the test data set. The test was the files that were not previously seen by the training algorithm. So it's a very good precision, a high recall, almost 96% for the child sexual abuse class. That's the interesting class. We had also a very, very good precision on the uninteresting files. Here are some statistics about the performance. So we could do, like in a modest legacy computer, a very old laptop, like 10 years laptop, we could do 35 images per second. What is the goal here? That usually a computer will have at least 100,000 images, an average computer. So we could do it in less than 60 minutes. I mean, 1 hour. That's, I think, a time that is enough to wait on the search warrant or any place to have a result. So in the training statistics of this model, you can see here the confusion matrix and the accuracy, the training graphics of the two phases. You can see clearly the two phases here different, and the classification report. I have another slide here that I show quickly, that we use this same data set, can be used to running on lab. So we have a huge model that we did transfer learning that's much more precise, but has to be run on a GPU. So here are the key achievements. So we had a good accuracy, better than our target of 90%, a good recall, really fast, portable, and open source methodology. You can download the source code is integrated, have been accepted to the main source of this iPad forensic tool. It's available on GitHub. So the operational and occupational benefits. So you can do a triage on the same day, like in less than 1 hour. With this, you can prioritize your material being search, you can reduce the backlog because you can prioritize, and even accelerated victim identification, finding new files. Occupational health, reduce exposure to traumatic content. So there are some limitations. We have this limited data set of child sexual abuse from Brazilian Federal Police. We only do some frame extraction for video processing. It doesn't access directly smartphones, must focus on computers. Future research, some better AI-generated child sexual abuse detection and better video analysis. And these GPU-optimized larger models, we already are working on that, and we have some good models already. Okay, that's my 12 minutes. Thank you.
Thank you for your presentation. I think in some way you mentioned about the SHA-1, right?
Sorry?
You mentioned about SHA-1.
Oh, yeah, that's
Secure
correct.
hash algorithm. What's the purpose and why not the other versions of SHA?
Yeah, that was used only for on the dataset preparation, only to remove duplicates. And we have also in Brazilian Federal Police a huge data set of hashes. So we have MD5, we have SHA-1, and have some different algorithms too. But the iPad framework already has a default hashing algorithm. I think it's SHA-1 and MD5. So all the 4 million files that we have already known, abuse files that we have on this data set, are usually on this hash format. So we use that too.
What do you mean by low resource forensic environments?
Just a minute. Sorry, I couldn't understand.
What is low resource forensic environment?
Oh, yeah, that's an important part. Low resource, I mean, that's like when you're doing a search warrant, is a normal computer, like a CPU computer. Usually for these AI classification algorithms, it would be desirable to have a GPU, a good graphics card. But this was low resource to run on modest computer power, like a CPU. Like I talk about the 10 years old laptop with only a modest CPU, and you can work on that because the model that we choose for the transfer learning is very lightweight, it's very fast.
Okay, thank you for your answers. I'm done.
Thank you so much for your insightful and well-presented talk.
Okay, thank you.
Moving forward, I would like to call upon the next presenter, Niroshi Piraveen, to present her paper on enhancing early detection of ADHD in New Zealand using AI-supported management information systems. You may present your screen and start with your presentation.
Yes, sure. I sent a request to you to share the screen.
Yes.
Okay. Hello to everyone.
So just one request, once you are presenting, please turn on your video.
Okay.
Thank you.
Hello to everyone. I am Niroshi Praveen. My paper ID is 486. Today I will present my research on enhancing the early detection of ADHD in New Zealand using AI-supported management information systems. This is the flow of my presentation. ADHD affects approximately 5 to 8% of the school-age children globally. In New Zealand, delays in diagnosis caused by the fragmented care pathways, limited specialists, and the inequities affecting the Maori, Pacific, and rural communities. Current diagnosis relies heavily on subjective questionnaires, which may delay intervention. This highlights the need for an AI-powered, scalable, ethical decision support system. The study of the aim of this study is to develop and evaluate the AI-supported management information system to identify the risk ADHD. In the study, there are three main objectives. First, to develop an AI-based predictive framework for early ADHD risk detection. Second, to evaluate and compare the supervised and semi-supervised machine learning models. Third, to integrate the best performing models into a scalable MIS architecture, which is suitable for the healthcare setting. The previous studies have applied the many machine learning models to detect the ADHD using the WEG, fMRI, and the behavioral data. Most of the research focus on the clinical data sets and do not address the national MIS integration. There's a limited research integrating the AI models into a scalable, governed, semi-supervised MIS integration. This study investigates how AI can process behavioral and clinical data, and what are the technical requirements needed for the integration. And finally, third one is to how ethical consideration that for the Maori and Pacific rural communities. So this study follows the quantity data-driven approach, and this flow diagram shows what are the techniques used in each phase. We use the NHIS 2024 child supplement dataset with the 8,060 child respondents from 358 variables. We retain to 106 variables using the data dictionary across the conceptual domains. There are totally 6 conceptual domains. So there are from the data set, some of the example variables according to the each of the conceptual domains here shown. In the data cleaning, first missing values were handled according to the NHIS standard. Then numerical and categorical variables are imputed using the mean median mode. After that, skewness inspections have applied to improve the skewness. Here we use the 3 transformation techniques, Johnson, square root, and the log transformation. After that, features standardized and the one hot ordinal encoding used. Then we identified on our data set there are 2 target variables. One is the ADHD ever diagnosis that is fully labeled, and other one is the ADHD now diagnosis that is partially labeled. So we thought to do the supervised and semi-supervised. For that, first we did the we addressed the class imbalance using the SMART technique on only on the training data set after stratified splitting. We split the data set into 80 to 20%. So this is the this graph shows before and after apply the SMART technique on the data set. We applied the multiple feature selection techniques, including the chi-squared, ANOVA, recursive feature elimination, lasso regularization, and the light GBM. Feature consistently selected across these methods were retained. Then, after statistical filtering, a final subset of 20 predictors were retained for predictive modeling. So, these two heat maps showing what are the numerical and categorical predictors finally retained for the predictive modeling. After that, among these 20 predictive factors, top ranked factors identified using the light GBM. So here, highest ranking predictors mostly on the socio-economic stress indicators, parental and child age demographics, behavioral control difficulties, and the mental health medication usage indicators. Then first, during the supervised learning, I choose the logistic regression, support vector machine, random forest, and the gradient boosting to do the ensemble models. Here, finally, after the supervised model, I found two best ensemble models. Those are logistic regression with a random forest. That is because of the high recall. I choose this for the early screening. The next one is the logistic regression with the random forest and the gradient boosting. This has the high precision. I choose this for the confirmatory diagnostic. We further applied the semi-supervised self-training on the partially labeled data ADHD now diagnosis. So these tables compares the different ensemble models. Here the logistic regression and the random forest ensemble model is highly sensitive and correctly identifying about 73% of the ADHD cases. This is ideal for the early screening. And when we add the gradient boosting with this same ensemble model, we got the higher overall accuracy and the balanced precision. This is best choice for the confirmatory diagnostic. The other models provide the trade-off between the sensitivity and the precision and can support the different stage of the diagnostic process. So this is the result. The confusion matrix shows how well the models identify the ADHD and the non-ADHD cases. In this confusion matrix, the logistic regression with the random forest ensemble model correctly detect 73% of the ADHD cases and the 94% of the non-ADHD cases. That is make ideal for the early screening. And also, when we consider the next ensemble model, the logistic regression with the random forest and the gradient boosting, this model have the higher precision and the specificity and detecting the fewer false positive while identifying around 69% of the ADHD cases. This is making better for the confirmatory diagnostic. Overall, these matrices highlights a trade-off between the detecting the true cases and avoiding the false alarm. To further evaluate diagnostic reliability, we constructed this confusion matching in the same two ensemble models. The self-trained logistic regression with the random forest ensemble model achieved the 91.3% accuracy and detected about 76% of the ADHD cases, making it more sensitive model. And also it from the supervised learning in this semi-supervised learning from the 73 to 76% improved, and this is making a more sensitive, although precision slightly decreased. This trade-off acceptable in the early screening. And self-trained for the logistic regression with the random forest and the gradient boost model achieved the 92% accuracy with a higher specificity at the around 95% and the balanced precision, while its score was slightly lower, but it's better suited for the confirmatory diagnosis. In conclusion, this research demonstrates the AI-driven data decision support system can play a transformative role in early ADHD detection by combining these two high recall screening and the high precision confirmatory diagnostic. The AI ADHD MIS framework provides a scalable, evidence-based supports for the early intervention. There are some limitations found in the research because I choose the NHIS US based dataset instead of the New Zealand dataset because of the the New Zealand dataset not available on the public access. So I choose the NHIS dataset for my research. In the future work, I decided to continue with the New Zealand specific dataset, and implementing that system in a real world clinical education setting for the practical testing. So these are the main reference for my research studies. Thank you.
Thank you, Nirushi, for the wonderful presentation. You
Thank you.
opted for the data set. Can I see the data set if it is available with you? Or can you just elaborate the number of parameter that it has in the data set?
Yes. This is fine. After the feature selections, I have the parameters, but do you want the original data set?
So how many records you have? How many features you have?
Totally, in the original data set, there are 358 variables. Then I reduced to 106 because I had to find out the related ADHD variables.
So how do you
So
know that 106, 106 are the required one, not the other one? So how, on what parameter you rejected the other parameters?
I did this one manually because in the same NHIS with the data set, they uploaded the another PDF that is contain about each of the variables, what is related to. So based on that document, I manually find out which are the variables related to these ADHD detection using the by creating a data dictionary.
Okay, thank you for your answers.
Thank you.
Thank you so much, Niroshi, for the presentation that you presented and the knowledge that you shared with us.
Thank you.
Moving forward, I would like to invite our next participant, Nu Hien Jiang Dao, to come and present her paper on evaluating machine learning models for credit card fraud detection under severe class imbalance, a comparative study of random forest and gradient boosting. You may present your paper by presenting your screen.
Okay. Can you hear me?
Audible.
Okay, so can you see my slide?
You see your screen.
Okay. So, good evening, distinguished chairs, esteemed members of the organizing committees and fellow researchers. My name is Dan
Hi.
Yin Yang.
Can you
And-
make it full screen?
Oh, what? Can you see my screen?
Can see your screen. I think the session chair is asking you to fit the presentation on the screen.
The presentations. So on the screen, can you see my slide?
Yeah.
So now can I start our presentation now?
Yes, you can start.
Okay, so good evening, distinguished chairs, esteemed members of the organizing committees and fellow researchers. My name is Dan Uyin Yang, and on behalf of our research group from the University of Economic Ho Chi Minh City, I am honored to present our paper titled Evaluating Machine Learning Model for Credit Card Fraud Detection under Severe Class Imbalance, a comparative study of random forest and gradient boosting. So, our presentation is structured into 5 key sections. So now we will move to the first sections. Number 1, introductions. So why is this topic critical today? In the digital era, credit cards had become the leading payment method due to their speed and efficiency. However, this convenience comes with alarming fraudulent activities. In 2024 alone, 62 million Americans experienced credit card fraud. Remarkably, only 8% were due to physical card loss, while 92% were caused by remote access to personal data. Traditional rule-based systems are no longer effective against the sophisticated technique because they lack self-learning capability. The primary technical challenge we face is severe class imbalance in real-world datasets. The fraud rate is as low as 1.172%. Standard models often become biased, achieving high overall accuracy by simply predicting every transaction as legitimate. While failing to detect actual fraud. So, our research aims to address these issues through 4 main tasks. The first one, we focus on undersampling method. Second one, we compare the performance of random forest and gradient boosting. And the third one, we evaluate this model by using advanced metrics that are sensitive to fraud. And the final one, we select the most effective model to minimize both financial loss and customer inconvenience. So the research community has shifted from early models like logistics, regressions, and KNN to ensemble method to improve performance on complex data. However, we identify a significant research gap. Most studies rely on misleading metrics like accuracy or AUC or OC alone, which don't fully reflect effectiveness in imbalanced scenarios. Also, we fill this gap by focusing on fraud-sensitive indicators such as precision, recall, F1 score, and the MCC. So now we move to methodology. Our proposed model architecture consists of 3 stages. Now, the first one is data pre-processing. We apply Z-score standardization to normalize the data, ensuring features are on the same scale. We use random undersampling to balance the distributions. By reducing the majority class, the model can more efficiently learn the pattern of fraudulent behavior. And number 2 is model development. We selected random forest and gradient boosting due to their stability and ability to handle complex functions. And the final one, we will discuss fraud-sensitive indicators such as precision, recall, F1 store, and MCC. So now we move to result and discussion. The original data set contains over 284,000 transactions. After undersampling, we created a balanced Jennings set of 10,000 samples with a fraud to Jennings ratios of approximately 1/19, and the fraud rate is about 5%. Crucially, our test set maintains the natural distributions of the original data. This ensures our results reflect real-world operational conditions and how the model would actually perform in a lived environment. And as shown in the table, both models perform exceptionally well, but there are key differences. Both models achieve an identical record of 0.842, meaning they detected the same number of fraud cases. However, random forests achieve a perfect precision of 0, whereas gradient boosting were at 0.941. Random forest also recorded higher F1 and MCC score, suggesting superior overall accuracy in both detecting fraud and limiting false alarms. And the confusion matrix. The confusion matrix in the figure clarify these results. Both model correctly identify 16 fraud, but miss 3. The distinction lies in false positive, gradient boosting mislabel, one legitimate transaction as fraud, while random forest has 0 false alarms. So random forest perfect positions prevent legitimate customer from being blocked. The ROC curves show both models have high discriminative power, with AUCs around 0.97, meaning they are both highly effective at ranking transaction by risk. They are equally strong at ranking transactions, so our final joy depends on the specific error types, false alarms, and misforms. To increase model interpretability, we analyze important feature V17, V14, V12, and V10 were identified as the most influential for detecting fraud. Focusing on these key features allow us to build faster, more efficient monitoring system. We must note a technical limitation regarding interpretability because the dataset uses PCA's transform variable to protect user privacy. While we know which components are important, linking them back to specific original behaviors like transaction velocity or location require a back project analysis of the component loading. This is an essential step for institutions that require explainable AI for regulatory compliance. So, why random forest is preferred choice? In summary, while both models share identical record and similar AUC score, random forest is the superior choice for absolute decisions. In the financial sectors, preventing false alarms is vital for protecting the customer experience and avoiding the cost of manual verification. Therefore, we recommend random forest as the more balanced model for institutions that prioritize customer satisfaction alongside security. Our findings have significant business implications. Random forests perfect positions is operationally advantageous because it minimizes customer frictions by eliminating forced card blocks and unnecessary investigative tasks. However, the record challenge remains, and both models miss three for cases. Therefore, we propose a two-stage pipeline. Stage 1, Deloitte random forest for real-time blocking to protect user experience. And Stage 2, implement rule-based scoring or manual review for low confidence transaction to mitigate losses from misfraud. And the last one, conclusion and future work. In conclusions, our study reaffirmed that while both models are very powerful, random forest is the safer choice for balancing security with customer experience. In the future, we plan to explore advanced algorithms like XGBoost and deep learning, as well as hybrid resampling technique like SMOTE or to future improved record. Thank you for your attention, and we are now open to any question.
Thank you for your presentation, but no question from my side.
Then, thank you so much, Miss, for that wonderful presentation. It was really impactful. Moving forward, I'd like to call upon our next presenter, Hima Pulumbarit, to present his paper on mapping AI and UAV research in rice health monitoring and crop insurance. I would ask you to present your screen and start with your paper.
Thank you, Madam Mod.
You can see your screen, sir.
Have you see my screen? Here. Sorry. Okay, do you see now?
Yes, sir, you can see it.
Okay. Okay, so again, good afternoon in London and good evening in the Philippines. So my paper is mapping artificial intelligence and unmanned aerial vehicle research in rice health and monitoring and crop insurance. I'm Jaime Pulumbarit from Bulacan State University, Philippines. So these are my outline of my presentation: introduction, the study design, the objectives of the study, methodology, results, conclusion, and recommendation. AI and UAV technologies are increasingly being integrated into agriculture systems to overcome the limitation of traditional monitoring methods. UAV equipped with multispectral, high-spectral, and thermal sensor can capture high-resolution imagery of rice fields, enabling early detection of crop anomalies such as pest infestation, disease outbreaks, and nutrient stress. Despite this promising development, the research landscape remains fragmented. Studies vary in their methodological approaches, geographic focus, and thematic priorities. To address this gap, the present study employs bibliometric analysis to systematically map the intellectual structure, collaborative networks, and thematic evolution of research on AI and UAV applications in rice health monitoring and crop insurance. Bibliometric analysis provides a framework for evaluating its scientific output, identifying influential contributors, and uncovering emerging trends. The objectives of the studies are map research landscape on AI UAV integration in health monitoring and crop insurance, analyze publication trends and growth trajectory, identifying prolific authors, institutions, and countries, examine the keyword co-occurrence and thematic clusters, and explore collaborative networks and co-citation patterns. In these studies, there are 4 steps. Step 1, data was sourced from a leading academic database, ensuring coverage of peer-reviewed articles and conference proceedings relevant to on AI UAV integration in rice health monitoring and crop insurance. The data was exported into bibliometric tools for network visualization, co-citation, and co-occurrence mapping. The step two is to visualize the conceptual and social structure of the research domain. Co-citation analysis, co-authorship analysis, and keyword co-occurrence analysis were performed using the BOS viewer. Co-citation analysis helped identify clusters of publication frequently cited together, revealing the thematic groupings and intellectual foundation of AI-UAV integration in rice health monitoring and crop insurance. The co-authorship analysis examined collaboration patterns among researchers and institutions, highlighting key contributors and research networks, while the keyword co-occurrences analysis mapped the relationships between core concepts and emerging toppings, enabling the identification of research hotspots and future trends, especially those related to AI UAV integration in rice health monitoring and crop insurance. The third step is using Boss Viewer, Elicit, SciSpace, and the bibliometric are packaged via BiblioShiny. Co-authorship networks were generated at the author, institution, and country levels to analyze the pattern of research collaboration. These tools allow the identification of clusters, key themes, and temporal trends. In the last step, to ensure the reliability and validity of the bibliometric analysis, a systematic data processing and cleaning procedure was implemented, guided by the PRISMA protocol. So in this approach, enhance the transparency and reproducibility of the study methodology, particularly in the selection and refinement of bibliographic records. What are the results? First, the initial search yielded a total of 19,328 documents were then refined through inclusion and exclusion criteria. These records are subjected to a multi-stage screening process. In the identification phase, all retrieved documents were exported in CSV formats, including metadata such as title, abstract, keywords, author affiliation references, and citation. During the screening phase, duplicates were removed and non-English documents were excluded to maintain consistency in language analysis. In the eligibility phase, inclusion and conclusion criteria were applied. Research studies were included if they focus on the application of AI and UAV in rice health monitoring and had direct or indirect relevance to agricultural risk assessment or crop insurance. Excluded were studies that focus on non-rice crops, lack empirical or apply AI UAV methodologies, were purely conceptual without biometric relevance, and fell outside the 2018 to 2026 publication window. The most prolific contributors to this research include the following: Lu Yong, Sang Yumen, Gonzalez, and others. These authors are recognized for advancing UAV-based monitoring, remote sensing application, and AI-driven pest and disease detection. The institutional productivity is largely concentrated in Chinese university, with notable contribution from research hubs in Australia, United States, and Europe, reflecting the global scope of UAV and I agricultural research. So the top institution contributing to research on AI and UAV application in the rice health monitoring and crop insurance, the National University of Defense Technology leads with 664 articles, following by the other universities. Most relevant sources identify the leading publications outlets such as remote sensing emerging as the dominant source, followed by the other journal. These journals and proceedings demonstrate the interdisciplinary nature of the field, bridging computer science, engineering, and agricultural sciences. Keyword co-occurrence analysis reveals that unmanned aerial vehicles, deep learning, drones, machine learning, and remote sensing are among the most frequently used terms, indicating a strong methodological and technological orientation. The whole citation reveals five distinct thematic clusters that reflects the evolution and diversification of research integrating AI and UAV technologies in agricultural monitoring. So this cluster represent foundational and emerging trends that have shaped the scholarly landscape. In conclusion, on the practical side, the study offers valuable insight for stakeholders across the agricultural value chain. For farmers, especially those in rice-producing regions vulnerable to climate variability and pest outbreaks, the adoption of AI-enabled UAV systems can significantly enhance decision-making. These technologies enable early detection of diseases, nutrient deficiencies, and pest infestation, allowing for timely intervention that reduce yield losses and input costs. For agricultural extension services and policymaking, the finding highlights the need to invest in digital infrastructure and capacity building programs that facilitate the adoption of AI/B and I technology. In the context of crop insurance, the integration of UAV and I technology offer new avenues for innovation. Insurers can leverage hazard resolution, imagery, and machine learning models to assess crop damage more accurately and efficiently, reducing the time and cost associated with traditional field inspection. The study also implication for research funding and academic collaboration. This study provides a roadmap for research seeking to enter expand their work in this domain. Funding agency and academic institution can use this insight to design collaborative research programs that leverage complementary expertise across discipline and geographies. Thank you for your listening.
Yeah, thank you for your wonderful presentation.
Thank you, sir.
So, what do you think the future of UAV?
What is the future?
Looking at the
Actually,
advances in AI.
The future of UAV, especially in the Philippines, especially in our region, it is very helpful tool in our farmers, not only in our farmers, but also to the crop agent insurance agency of the Philippines. Actually, this study have initial talk with Philippine Crop Insurance Corporation to we will help them in order to monitor and to help in monitoring the crops and the rice during the time there is a typhoon and there is a flood in the Philippines, especially in the rice field area.
As we have different kind of threats or security issues because of this AI and agentic AI, do you think UA will be vulnerable?
Come again, sir.
Do you think there will be vulnerabilities in UAV?
We think we can.
Do you think there are security issues in UAV?
I don't think so. There is no issues as long as they will use correctly and utilize correctly the UAV.
Okay, thank you for your answers.
Thank you, sir. Thank you, Madam Moderator.
Thank you so much. We appreciate the time and effort that you put into delivering such an excellent presentation.
Thank you, sir. Thank you.
Next, I would like to move forward with our next presenter, Nicole Ellsbury.
Hi, hello. Okay, hold on one moment. I'm just getting my screen.
Hello, yes, ma'am. You can present the paper, ma'am.
I'm working on it. Disable share. Oh, I think the previous presenter needs to, or someone needs to stop sharing. It says disable share. You cannot start screen share where others are presenting. Okay, I want a window. There we go. Okay, is it visible?
Yes, it's visible.
Okay, great, perfect. Okay, so good morning, everyone. Oh, sorry, I should go back to the first slide. There we go. Okay, good morning or afternoon, everyone. I'm Dr. Nicola Musri. On behalf of my co-authors, Dr. Olga Barokina, Dr. Bashak Ozarel, and Fatima Shamsuddin from Prince Mohammed bin Fahd University in Saudi Arabia, I'm pleased to present our study, Perceived Benefits and Challenges of Using ChatGPT by Saudi Arabian University Students, a Gendered Perspective. As AI has become a staple in higher education, understanding the nuance of student interaction is more critical than ever. So as an introduction and my research goals, our research is situated within the context of Saudi Arabia's Vision 2030, which drives massive digital transformation. And while generative AI is reshaping education globally, our specific objective was to investigate gendered patterns. We wanted to see how male and female students differ in their motives, their practices, and their perceived impacts of these conversational AI tools. Okay, so our problem statement and significance. The current gap in research is that most studies focus on technical capabilities. We noticed a lack of data on subjective experiences of students, particularly through a gendered lens. This study is significant because it provides the empirical foundation needed to create gendered responsive AI literacy curricula and transparent policies that reflect actual student behavior. Okay, so here we go. So we frame ChatGPT as a cognitive scaffold, allowing for cognitive offloading, which is where students can shift effort from rote recall to critical evaluation of AI-generated content. In the Saudi context, this is particularly relevant for language acquisition, as AI reduces anxiety surrounding complex academic writing tasks in English medium instruction. Go. Okay, so for our methodology, we utilized a constructivist paradigm and a quantitative design. Our sample consisted of 150 students from PMU and Al Khobar, that's Prince Mohammed bin Fahd University, in Khobar, Saudi Arabia, with nearly even split 80 male and 70 female students from diverse academic fields. We analyzed this data using descriptive and inferential statistics, including t-test and chi-square tests, to find significant divergences. So our key findings. Now looking at the data, we found three striking areas of divergence. First, 40% of females reported high engagement. Second, 58% of females strongly agreed on the personalization effects. This reaches statistical significance with a p-value of 0.036. And finally, 62% of males prioritize information efficiency, highlighting a more functional, output-oriented approach. Now let's dive a little bit deeper into the findings. So the gender split continues in the type of work performed. Female students gravitated towards language-related support, writing, editing, and translation to meet instructor expectations, while male students reported much higher confidence in using the tool for ideation, programming, and independent problem solving. Okay, finding 2, engagement and simulation. Female students reported a mean score of 3.3 for engagement compared to 2.86 for males. The skeptical male, 33.8% of male students gave negative skeptical scores regarding engagement. And females, 40% of the female students gave high scores, 4 or 5, for finding tools more interactive. Finding number 3, functional efficacy or efficiency. This is where the trend flips. Male students with a mean of 3.6 saw higher value in efficiency than females with a mean of 3.44. In practical use, men prioritize a tool for getting the job done, information retrieval, program, and problem solving, while women prioritize the process, editing, and feedback. So practical. So how is this used daily? Students use it for idea generation, to fill gaps in research, for preliminary market analysis, and for technical support like drafting formal business plans or academic writing. It has essentially become a 24/7 virtual tutor and technical assistant. All right, so the challenges and the barriers. The challenges are equally significant. Accuracy and hallucinations were cited by over 30% of our sample as a top barrier. There were also a fear of cognitive atrophy, which is the loss of original thinking due to over-reliance on this technology. Ethically, students remain concerned about data privacy and the robotic nature of output. Both genders worry about hallucinations, but specifically female were significantly more critical of the accuracy, and male students were found to be more lenient to potential gray areas regarding academic integrity. And students reported a lack of clear guidelines from universities. So why is there a gender difference? Why do these differences exist? Our studies suggest a confidence versus caution dynamic. Men often show higher technical self-efficacy, while women approach the tool with an ethics-first focus. We also found that for many Saudi students, the tool is a bridge for English medium instruction, a benefit felt most accurately by female respondents. So our implications for educational practice. This leads to three major implications. First, we must teach AI evaluation, not just usage. Second, faculty must adopt gender-responsive pedagogy, recognizing that some students need technical troubleshooting, while others need ethical boundary setting. Finally, universities must move towards transparent integration rather than bans on AI use. And as far as the limitations and future research, our study was limited to a single site and relied on self-reported data. For future research, we recommend longitudinal studies to see how these perceptions evolve as AI becomes more normalized in the student experience, as well as looking at specific differences between disciplines, like maybe medicine versus art. And in conclusion, ChatGPT is a powerful co-pilot, but its adoption is far from uniform. To truly realize Vision 2030 in Saudi Arabia, we must foster an AI culture in our universities that is ethically grounded, gender inclusive, and critically aware. We must empower students to use AI to enhance and not replace their human mind. Thank you very much for your time. I am now happy to take any questions you may have.
Yeah, thank you for presenting your topic on the current interest. Do you think ChatGPT or Gemini is a part and parcel of the academics now?
A part of what? I didn't catch the last part.
Do you think ChatGPT is a part of the academics now?
Oh, of course. Absolutely. I mean, they're using it with or without our consent or our teaching.
Yeah. And the second thing is you opted for a like 150 samples, right?
Yes, correct.
What was the method of selecting or picking up the candidates for the, say, questionnaire surveys?
We tried to reach out to as many colleges as we could to get a more varied response. I do believe we had, I think most of the responses, though, were in the business department. Most of them were or had a major relating to business. That is important to note.
Sure. Yeah, because the more tech students are using ChatGPT compared to other stream students.
True, absolutely. Well, they know how to use it better. They aren't necessarily using it more, right?
I think sure. In the future, you can have more tech students for your survey. Yeah.
Yeah, thank you. That's true. Absolutely. Thank you so much.
Thank you so much, Nicole, for that presentation. Truly amazing. Now, we'd like to move forward with our next presenter, Thao An Le. I would ask her to present her paper on YOLO V8 based automated classification of cervical transformation zones in colposcopy images.
Okay, just give me a few seconds to share my screen.
Sure.
Okay, can you stop sharing your screen? Okay, thank you. Okay, I hope my screen is visible to everyone. Can someone please confirm it?
Yes, your screen is visible.
Okay, thank you. First of all, I would like to express my most respectful greetings to everyone present here today. My name is Joanne, and today I am pleased to present our research titled YOLO V8 based automated classification of cervical transformation zones in colposcopy images. Okay, so here is the flow of my presentation. Now let's begin. The motivation behind this study comes from the fact that cervical cancer remains a major global health concern. Colposcopy plays a key role in cervical cancer screening because it enables direct visualization of the cervix, especially the transformation zones or TZ, where most HPV-related lesions develop. Clinically, TZ is classified into three types: type 1, fully visible; type 2, partially visible in the endocervical canal; and type 3, poorly visible and associated with a higher risk of sampling error. Accurate identification of TZ type is critical for reliable diagnosis. However, manual evaluation is subjective and depends on clinician experience, image quality, and anatomical variation. So this creates inconsistency and motivates the need for an automated solution. Recent advances in deep learning, particularly the YOLO model developed by Ultralytics, provide strong real-time performance. And in this study, we propose using YOLO V8 to address the unexplored problem of the transformation zone classification in colposcopy images. So before presenting our methodology, let me briefly position our work within existing literature. Early cervical image studies mainly use CNN model like ResNet and VGG to classify images as normal and abnormal, but they did not localize region or focus on transformation zone. Later, we have two-state models. They improve localization, but were too complex for real-time use. And more recently, we have the single-state model like YOLO, achieve better speed and accuracy, yet more research to focus on lesion detection or CIN grading rather than the TZ type classification. To address these gaps, we propose using YOLO V8 to address this problem. And now I will describe our methodology. For the dataset, we created images from the Intel Mobile ODT Kaggle competition. After strict quality filtering, around 1,600 images were retained and categorized into TZ type 1, 2, and 3. Then images were resized to 640 by 640 pixels, augmented threefold, and split into training, validation, and testing sets. The final dataset consisted of 3,090 labeled images. We selected YOLO V8 CLS, a medium scale classification only variant. The model used a CSV backbone and multi-scale feature aggregation, initialized with ImageNet pre-trained weights. Training was conducted for 100 epochs with a batch size of 32. For evaluation, we use accuracy, precision, record, F1 score, macro F1, confusion matrix, and ROC curves. And now let me discuss the results. So on the test set of 307 images, our model achieved a top one accuracy of 74.27%. F1 score were 0.77 for type 1, also 0.77 for type 3, and about 0.68 for type 2. The macro F1 score was 0.74, and importantly, the model runs at 1.7 milliseconds per image speed on an NVIDIA A100 GPU, demonstrating real-time feasibility. And we also compare our model with the newest version of the YOLO model is YOLO V11. We compare it under the same testing condition and represent it by ROC curves. And as you can see, the YOLO V8 achieved higher AUC values across all three classes, especially for type 3. Type 3 is the light blue line here, as you can see on the screen. And this indicates better stability and separability. Figure 2 shows the confusion metric results. So overall, YOLO V8 performs better than YOLO V11. For YOLO V8, the model correctly classified 85 type 1 cases, 69 type 2 cases, and 74 type 3 cases. In comparison, YOLO V11 has fewer true positives, meaning it misclassifies more sample. And this highlights that YOLO V8 achieves a better classification performance across all three TZ types. Qualitative results provide additional insight. Here is the TZ identification based on the squamous-columnar junctions visibility, or you can call it SCG visibility. So this is the area where two different types of cells meet. This area is important because most cervical abnormalities and early signs of cervical cancer start around this junction. So in the correctly classified images, type 1 show fully visible SCG, while type 3 so deeply located and non-visible SCG. Type 2 exhibit intermediate characteristic. However, error analysis shows that type 2 is the most challenging class. About 17.7% of type 2 cases were confused with type 1 and type 3. So this is mainly due to the loss of depth information in 2D images. Lighting conditions such as glare and shadow also contribute to misclassification. So compared to traditional model like the CNN, our accuracy is comparable. However, the major advantage of our approach lies in real-time processing capability, which is essential for a clinical decision support system. So in conclusion, our study demonstrates that the YOLO V8 CLS provides an effective and real-time solution for cervical TZ classification, while type 2 remains challenging. Our study shows strong potential for integration into computer-aided diagnosis systems, particularly in resort-limited settings. And in the future, we plan to integrate detection and segmentation models to better localize the transformation zone boundaries and extend that framework into CIN grading tasks. And we believe that our approach has the potential to support clinicians, especially in the area where experienced colposcopists are limited. So that's all for our presentation. Thank you for your listening and your attention. And our team welcome your questions, and my teammates will answer the questions.
So do you have any questions for them?
No questions.
Okay, thank you, sir.
Thank you so much for such a well-structured and enriching presentation. Now, I would like to conclude. I would like to conclude this session by sincerely thanking our authors for their excellent presentations and valuable contributions to this session, and all our participants for being a part of this international conference. I hope this session was informative, enriching for everyone. All the presenters will receive their digital certificates via email within 2 days. The publication will be live within 7 to 8 weeks. Kindly cooperate with the ICICT 2016. On behalf of the entire team, thank you for your continued support through the 11th edition and all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. Now, as a token of appreciation, I would like to display this certificate to our session chair on Team CICT 2026 and Global Knowledge Research Foundation and partners. I would now like to invite Dr. Prashant Dhotre to give his closing remarks.
Yeah, thank you, Pranjal. I have witnessed the diverse presentations today across the globe, from the perspective of AI, from the perspective of medical domain or health domain, and the authors have presented their presentations in a wonderful way, structured manner, and the contribution is really good. So thank you for the opportunity and wish you good luck. Have a good day.
Thank you so much, sir. I extend my sincere gratitude to our session chair for chairing the session with his great energy and his valuable presence and guidance throughout the session. Now, I would kindly request all of you to switch on your cameras for a quick snapshot of the virtual conference for valuable memories to display on the website. I would request everybody to turn on their videos. Just a moment, guys. I hope everybody is able to turn on their videos. Everybody has been granted the permissions. Okay. Ready? Everybody smile. Thank you so much, everyone. It was such a wonderful session. It was my honor to host you all and listen to all of your presentations. Stay safe, take care. Bye-bye. Bye-bye.